So between functions and scripts, we can do a lot of interesting things. So not only can we use the scripts to say, here's a series of protocol or a series of mathematical operations or logical operations to do, but we can actually use them in conjunction with functions. So for example, in my first program, in that script, we can take that x and that y, and we can now put in our function call, my first function. Here we can put in x comma y, and it will save that variable now in A. So let's see what happens when we run the script. So keep your eye on A. So we run the script. Oh, it didn't change because the number was the same. Well, okay. So now I have 25 and 7. I can now change my script to maybe y is 30. Now keep your eye on A. When I hit enter, A now changes because the script, that A is written into memory. So the last thing that I want to sort of cover in this, or the second to last thing that I want to cover into this very basic intro is the fact that x and y are being passed into my first function. But this x and this y are not the same as this x and this y. We can see that if we change my first function. So in this case, we're adding them together, so the order doesn't matter. But let's take the case where I subtract one from the other. So because I've made a change in my first function, I need to save that. So here I'm going to say x minus y. So, and it's going to take that square root. So let's put x is bigger than y, otherwise we're going to end up with an imaginary number. We can say x is 30, y is 20. So now when I hit enter, I have the square root of 30 minus 20, or 10. So we can check if A is giving us the square root of 10. Down here in the command window, square root 10. Oh, that's exactly what we expect. So this is going to matter because let's say I swap these. I say y comma x. When I pass this, when I pass these variables through, it's going to put y in first, then x. Matlab is going to take that variable that comes in first and assign it to x. Right? So when I run this, I should expect an imaginary number because I should end up with 20 minus 30. And so when I click run the script, that's exactly what happens. I end up with an imaginary number. Even though y is still less than x in my script, I'm putting in the small number is going in first, then the big number. In essence, right, we're seeing the variables y and x, but Matlab is literally writing this as 20 and 30. Okay, so this is a key place that young programmers or new programmers tend to get mixed up is these variables aren't going to get passed back and forth. Good. So as we're writing code, it's going to be very important that we document what our code is doing. This is because we might forget that my first function takes the first variable minus the second variable and does the square root. So we may want to write some things into our codes, whether it's a script or function, that tell us in human readable form what's going to happen. So these are called comments. So to do a comment, we use this percent sign. And so now I can write anything into this comment that I want, and MATLAB will not try to interpret that as a mathematical function. So what would be useful to say is, this will take the first number, subtract the second, and take the square root of the difference. Okay, so now when I click go, or when I click run, MATLAB will execute the first line, so it'll store 30 in the variable x. It will store 20 in the variable y. It'll come down to line 5. It will see these percent signs and move immediately on to number 7, where it will pass x and then y into my first function and store the result in that a. So when I click go, I'm now back to my positive number because I put in x and y, and nothing happened with those percent lines. So it can be very helpful when we're writing functions to say, write out in human readable form, this is what I want to happen. And then you can put in the actual code that you're interested in. So here in my first program, we've gotten away with clicking this run. What happens if I try to do that in a function? If I go up here and I click run, I get errors that pop out. So I click run, it says my first function, not enough input arguments. Because when I click go, it's trying to run this, this saved file. But the saved file, that function expects 2 inputs, x and y. When I click run, there's nothing that actually, we haven't given any input arguments. So MATLAB tells you this by having this red script, which says not enough input arguments. And it even says where the error occurs. Error in my first function, line 3, right? This error is because it doesn't know what x or y is. Remembering, of course, that the x and y in the workspace are not, what's in the workspace is not passed into the function, right? Essentially, like we've told the person in the next room over, here's the set of instructions, but we never give them the sheet of paper that says, this is x and this is y. So MATLAB will try to be helpful. So as we're writing functions in the class, it's very helpful to write this script, which sort of sets out these inputs and then runs the function. So then you can just click the go in the script and it'll test the function that you're trying to work on, just as a handy dandy debugging issue. Okay, so now, because here if I click run, it will run. Very lastly, before we go back, is this run in time piece. So this is useful if you want to see how long your program takes to run. So if I click that, it takes a little bit longer to pop up. But it gives me my profiler. So what this is going to do is it's going to show us how long each of my pieces took. So my first program took 0.001 second, and my first function took also 0.001 second. So if you're worried about things being slow, this will help you where things are slow. So you can also help with debugging by putting in, by clicking on this left side. So here I've put this red dot here. So it will, when I run this next, it will put in x equals 30, x equals 20, but it won't evaluate that. Essentially, it's going to stop the code just to make sure that the first few lines work. And in this case, it's very simple, and it will. So you can see there's this K as this breakpoint here, and we get this green arrow that pops in here that says this is the next line, and I can click this continue button, and it'll do the next step, which finishes the program. Or I could have gone in and clicked this quit debugging, and it'll just exit out of the entire program. Okay, so now let's go back and put sort of what we've learned into practice. Let's look at a basic chemical engineering problem. For example, let's take a case where we are interested in studying the water-gas shift reaction. If you're unfamiliar with this reaction, it's one of the most critical reactions in the economy. This is where we take carbon monoxide plus water, and we react these, essentially moving the oxygen from the water to the CO to form H2 and CO2. So this is critical in the production of fertilizers, fuels, and will become more important as we continue on towards the hydrogen economy. So let's say we want an easy way to determine the production yield, or how much reactant turns into a product. So how much of that CO and the water turn into H2 and CO2. In the case of the water-gas shift reaction, the chemical equilibrium is highly dependent on the temperature of the system. That temperature dependency of the equilibrium is given by this equation here, where equilibrium constant is 10 to the power of negative 2.4198 plus 0.0003855 times the temperature in Kelvin plus 2180.6 divided by the temperature, once again in Kelvin. So this will give us our equilibrium constant. And if you remember from general chemistry, we can relate the equilibrium constant to our conversion extent for this binary reaction as the following, where the reaction extent is equal to our reaction yield, here's the variable x, over 1 minus x times the quantity 1 minus x. Right, so here's our first model, our mathematical model of the system. So if we were able to solve these equations for x, I could give it any temperature, and it would tell me how much my reaction extent was. All I need to know is how to solve this lower equation, which if I multiply it all out and rearrange, we can get a quadratic equation of the form the quantity KEQ minus 1 times x squared minus 2 KEQX plus KEQ equals 0. A nice simple quadratic equation, which we know how to solve via the quadratic equation, where A is this first term, B is the second term, and C is the third term. Right, so let's go in and we're going to implement this in Matlab. So before we implement this in Matlab, we're going to build a scaffold. So just in words, how to solve this problem. Right? So we're going to build a function. So this is what our scaffold is going to look like. So first, we're going to write out what the function is supposed to do, what this code is supposed to do. So we're going to set function inputs, so our temperature, and outputs, and assign the name. Then we need to calculate K, and here I've written out the equation for K. Then we're going to calculate A, B, and C, right? So those were from the quadratic equation piece. Then we're going to calculate what X is, so X using the quadratic equation, and then we're going to tell the computer to return X to return our yield, right? So this is 1, 2, 3, sort of 4 operations that we need our model to do in order to figure out how much yield I get for a given temperature. So let's go back to Matlab and implement this. All right, so we're back in Matlab. So let's clear out some of our programs. So let me just close out these 2 different programs, and we still have all this stuff left over from last time. So I'm just going to use the CLC command to clear out the command window, and I'm going to use the clear command to clear out the workspace. So as you noticed, the workspace is now empty. My command window is empty. Well, aside from clear, and I can get rid of that. Okay, so let's go in. We're going to build a new function. Going to build a new function, just completely empty. And we're going to take all those words and the scaffolding that we had on the previous from PowerPoint and just put those in as comments so that we can sort of know our thought processes. So we're going to use that comment key. So, and then we're going to say the first thing that we need to do is set the function inputs t and output x and assign a name. Okay, so then we need to calculate k. Then we need to calculate a. We need to calculate b. We need to calculate c. We need to calculate x, and then return x. Okay. So we're going to tackle each of these pieces one by one. Okay. So the first thing we need to set the function input and output. So remembering back to how we build functions, so we say function, then comes our output, which is x. We need a name, so let's call this conversion. That's going to be our function name. Now open parentheses to say here's what's going to come in. We have a t for temperature coming in, and we're all set. Now remember, as soon as we put in our function, it's just good practice to come down to the end and hit end. Right, the benefit of that is it's already going to accomplish that last task of returning x for us. Okay, so now we need to do, so we've taken care of the first task. Now we need to do the second task, so in the scaffold, so calculate k. So here we can just type in our equation. So we have k is 10 raised to a power. So we're going to use that caret. And the equation from the previous slide was negative 2.4198 plus 0.0003855 times the temperature plus 2180.6 divided by t, close parentheses. Right? So this is going to operate just like, traditional order of operations. It's going to look first what's in the parentheses. It'll do the multiplications, and then it'll do the additions and the exponential. Okay, so just for our sake, we'll let it output the value to the screen. So we're ready to move on to calculate A. If you remember, we had A is equal to k minus 1. B was equal to negative 2 times k. C equals k. Now, we need to make sure that these are capitalized, because if they're not capitalized, it's going to recognize that as the wrong variable. Okay, so now we're on to that step 11, which was calculate x. So now we need to input the quadratic equation. So x equals, in parentheses, negative b. Now we have an issue because it's plus and minus, but the computer won't do plus and minus. We have to give it one or the other. So what we're going to do is we're going to put in x1, which will be plus, and then we'll do x2, which will be minus, and then we'll compare them. So b plus the square root of b squared minus 4 times a times c. So the key thing here is we can't just say 4ac. We actually have to type in the asterisk for times, or else the code won't know if AC is supposed to be A times C or AC is a variable. So now we're ready to close our parentheses. So when I put in that first one, it shows up and it says, it highlighted that in blue on that first one just so that you can keep track. One of the biggest places that people make mistakes is parentheses in the wrong spot. Matlab really, as with all computer programs, really takes those matched parentheses seriously. What you'll notice is there's this highlighted parentheses left. And so Matlab is helpful again, saying invalid syntaxes at end of line. This is because we have 2 open parentheses, but only 1 closed parentheses. So we need to essentially close that last parenthesis. So now Matlab is happy, and we're ready to do divided by 2 times a. Okay, so we can now do the exact same thing. I'm going to just copy paste for x2, changing from plus to minus to account for that other condition. So as of right now, we don't know whether we need the plus or the minus. So for testing purposes, let's just say x equals x1. Right? We can go back in if we were wrong, and we'll test to see whether we need the plus or the minus in a second. So now we've taken care of all the things that the scaffold told us to do. Return x. Well, it's gotten to the end. It has an x value. It's going to put that x back, so we're done. So what we need to do is we need to save the function as conversion, and we're ready to test. So let's type this in. So conversion in the command window. We can put in any temperature that we want. In this case, let's just see what happens if I put in 500. When I put in 500, we see that a whole bunch of stuff gets spit out onto the command window line. We see that we calculate a K, we have an A, we have we have the calculated B, we have the calculated C, and the calculated X1 and X2. So here's where we still need to use our logic, right? So X, remember, was the amount of conversion. Can I have more conversion than 100%? No. So what I really need is for, so X1 is coming out at more than 100. So, or more than complete conversion. X2 is less than 1, right? So I could have less conversion than total. This is the one that we want. So we want to go in here and change this x1 in our function to be x2. So when I run this again, now my final x, my answer, makes sense. So this is a lot that's being printed to the screen. So I can set it, put in all these, I can put in all of these semicolons so we only get the final answer that we're interested in. So let's save this. we can run it again here in the command window, and it looks great. So now let's see the power of this. So we're going to go into make a new script. So just by clicking that tab. So let's say I'm interested in looking at multiple temperatures. I can say temperature equals 400. And then we can call conversion T. And we could run this once. So when I run it, it's going to ask for a name. So we can call this test conversion. Hit enter, and oops, nothing's going to pop out because I had that semicolon in here. When I run this again, it's going to pop out what that conversion is. But I can do this for many different temperatures. So let's change this. So this is 300, 400. Power of copy and paste. 500, 600, 700, whatever. we can save this, and now when I click run, it's going to execute all of those different commands at the same time running on conversion. And we can see all those popping up right here. Let me clear so we have a nice fresh window. Right? So here I have all those different answers. And I could have gone in here and say x1, x2, x3, x4, and x5. And when I run this, I now have all those different values saved. Okay, so hopefully what you've taken away from this is how we can use scaffolding to build functions and implement these system models. We can use scripts to either do calculations or test those functions by passing variables into and out of those functions. Good. So now we've built our first function. We've built our first system model. And now it's time for you guys to practice. So we didn't get to this in class, and we'll get to this in the first part of class on Tuesday. But go ahead and try, if you want, to build a Matlab function, which is going to take in two numbers and divide the first one by 2 and return the answer. So in essence, if you submit 20 and 4 into the function, it should return 5, right? So 20 divided by 4 is 5. This is essentially what we want you to do. The code needs to have the name, your ASU write _ homework. So my ASU write name is cmuich, so I would type in cmuhich _hw1 for my function name. And submit that into onto sparky.fulton.asu.edu/chemi/384. On that page that was sent you, you can use that to track to see whether you got it right or wrong. And we'll do this at the beginning of next class. So in general, I hope that you now have a rough idea of how MATLAB operates. You know the difference between a function and a script, and you know how to run those in MATLAB. All right, I'll see you guys on Tuesday in class.